If you find the content relevant and really worth, please do share and subscribe for our channel. Let's start.
In the given figure here, it's said that quadrilateral ABCD is a cyclic quadrilateral. What does cyclic quadrilateral mean? When the vertices of the quadrilateral are on the same circle, then the quadrilateral is said to be a cyclic quadrilateral. So in a cyclic quadrilateral ABCD, diagonals AC and BD are perpendicular at Q. So diagonal AC and diagonal BD, they cut at 90 degree, hence it is said to be perpendicular at point Q. A line L bisects AB at P, passing through Q intersects CD at P, means there is a line L which bisects AB, means point P is a midpoint of AB. And the line which is bisecting AB, it is passing through Q and intersects the opposite side of AB, CD, at point T. We are supposed to prove line L is perpendicular to CD at T. So we are supposed to prove line L is perpendicular to CD at point T. In short, we are supposed to prove this angle made here, that is PTD, should be 90 degree. So then we can tell that line L is perpendicular to CD. In the above sum, some properties has to be taken from standard 9. So please concentrate on triangle AQB. In triangle AQB, so first let us make two columns: statement and reason. My first point, I will enter a right triangle. In right triangle AQB, measure angle AQB is 90. Can I tell? Because they are given diagonals perpendicular given. Is it right? So it's a right triangle. And P is the midpoint of AB. So can I tell QP is a median to hypotenuse AB? So I can put as PQ is median to hypotenuse AB. Therefore, I get a very important property. PQ will be half of hypo AB. Reason, median to hypotenuse. In right triangle is half of hypotenuse. Second part, we have P midpoint of AB. So can we put up PB is half of hypo AB. Reason for this is P midpoint given. Okay. Now if I try to club point number 1 and 2, I get something special because my RHS are equal. So point number 3, in triangle PBQ, if I take the relation from point 1 and 2, RHS are equal. So I get PQ is equal to PB. Reason for this will be 1, 2. So if PQ is equal to PB, if in my triangle PBQ, if PQ is equal to PB, is it an isosceles triangle? If it's an isosceles triangle, I'll get this angle here will be congruent to this, correct? So which are that angle is that I'll get angle PBQ is congruent to angle PQB. Reason for this will be isosceles triangle theorem. Okay, in triangle PBQ, we got, and because PB was congruent to PQ, PB was congruent to PQ, we got angle PBQ is congruent to angle PQB. That was isosceles triangle theorem. Now, if you concentrate PQB and angle DQT, these are two vertically opposite angles. So if I write point number 4, measure angle PQB is equal to measure of angle DQT. Reason for this is vertically opposite angles. Now we can have a link here. Just here, PBQ is congruent to PQB and PQB is congruent to DQT. 1 is congruent to 2 and 2 is congruent to 3. So can I put 1 congruent to 3? So I get a relation, point number 5, angle PBQ is congruent to angle DQT from point number 3, 4. Now I can just increase one of the sides of angle PBQ. Take a PBQ can be written as ABQ. So therefore, I can write angle ABQ is congruent to angle DQT. Reason for this, we can put A dash, P dash, B. Okay. Now, point number 6. In point number 6, we'll try to enter two triangles. Just check it out. The triangles are AQB and DPQ. In triangle AQB and triangle DTQ. If you concentrate on this triangle, please check it out. Just now we have proved one of the angles, which is that two angles which is congruent. The first angle is that angle ABQ is congruent to angle DQT. We have already proved in point number 5. It is from point number 5. Next, if you check properly, you will come across these two angles are congruent. This angle here is congruent to this angle here. Check it out. This particular angle is congruent to this. If you write 3-letter name, what I'll get is that angle BAQ is congruent to angle QDT. Is it angles inscribed in same arc? So we have an arc, this particular arc. Can you see this particular thing? In this particular arc, there are two angles. One angle is ABAQ, other one is QDT. Okay, therefore the two angles are congruent because it's angles inscribed in the same arc. So hence what I get is that triangle AQB is similar to triangle DTQ by AA test of similarity. Now if the triangles are congruent, I get angle, measure of angle AQB should be equal to measure of angle DTQ, reason corresponding angles of similar triangles. But if you see properly, AQB is 90 degree. So can we put up something like this? But measure angle AQB is equal to 90 degree because diagonals perpendicular given. So therefore I get measure angle DTQ is also equals to 90. So can I put it up from point number 6? Okay, so once I get DTQ is 90, once I get angle DTQ equals 90, we can tell if DTQ, this angle DTQ comes equal to 90 degree. So we can tell therefore line L is perpendicular to seg CD at point T. Hence it is proved.